Hey guys, I want you to see what I'm using. Their engineer, their expert forensic guy, says it reached approximately, the experts in this, approximately 32 degrees is where it meets the deck. Well, I have it 34 degrees. Per the drawings, I have it meeting at 34 degrees. So how can they be off so far by saying it meets approximately 32? Well, you're creating more of an incline by saying 32, more of in their favor. But I'm going to make this out of steel for you guys. I'm going to weld up something, and we're going to load it right there at that top right there, and we're going to see if it can push out number 11. I'm going to weld a joint similar to that joint there. Well, I might put a piece of steel on. I just might weld them intersecting each other without the chamfer. We're going to load it at the top, and we're going to see if it deforms, because they have this sliding on its own with no deformation happening up here between 10 and 11 or down here between 9 and 10. They have this thing acting like it's a flexible unit that can flex, when clearly post-tension bars are number 10, not allowing for flex. They're in clamp force. They're not allowing for flex. And so I'm telling you, the lobbying thing, it just paid off, and it's a terrible report, and I would never trust NTSB based on this report. I won't say again because I don't do stuff like agains, the agains or if onlys, but it's terrible. Let's move on. Again, that's 34 degrees. See it? 3-4. I got to put that little flatter against there for you. Right there. Try to make sure it squares up. 34 degrees. Now I can probably, let's see how the max I can get to tilting the camera. So tilting the camera, the max you get is what, 33.5, and then I tilt the camera this way and you get 35.5. So that you split the difference and you'll know where the real center line is. It's 34 degrees. Okay, per Engineer, Architects, Material Scientists, Concrete Placement 4.14. As illustrated in Figure 4.1, the specimens were cast in 2 lifts with a slope construction joint at mid-height. The angle of the construction joint relative to the longitudinal axis of the specimen was 31.8 degrees. I said 32, right? 31.8, matching the angle between member 11 and the concrete deck. I don't know where they're coming up with 31.8. Because it's 34 degrees. You guys can do that yourself. You can grab anything you like like this guy here and put it on there and square it up. This has a 90 degree and a 0 degree right here. So I line up the 0 and the 90 with a dot where they meet together on the structure, and then I can use that as my reference point, and I come up with 34. So one more time again, I'll line up with this, and I'll put the dot on there where they meet, the center dot. I have other things I can use, but I think this one was most best for this video. So I'd line up the dot, I turn the 90 to touch, line the dot up, and if this is squared, it'll just about reach the 0 there too, to the left. I got to turn a little better than that. A little better, let's see, 30, 0. This is not flat. Hold on, I've got to bend it a little bit. Trying to get it flat, guys. Sorry about that. I gotta get this flat. Hold on. Okay, the error I was making was that I changed the scale on my, I had this enlarged. I had to put it back to 100%, the background scale of the computer screen. And there we are, back to 34. And so I can't do any better than that for you guys. 34, 30, 34, 34, 34, 33, 33.5, about 34. I'd say, let me push that in there real tight. Man, it's a tough one. 34.5. 34.5. Trying to do two angles here. There's 35. And if I push it there, it's a little bit over 34.5. It's about 34.6. I can't get it come down to 34 when I go that direction, but I can get it to go up to 35 on that. I mean 34 over here. And I can't get it to come down to 33 here. So let me correct that. Let me say 33, not 34, 33.5. 33.5. So how can they say it's something different? So how did they get to 31.8? I don't know how they came up with 31.8. So I want to make this model up and test it for you guys, but I have to be fair. I don't know whether to use the 31.8 or the 34.5 or split the difference. It would have more of a chance of sliding the more I go down. But I do have an intersecting member that's going to get welded also. And that's this member here. So I'll weld this joint here. But I want them to meet, you know, close to fair as possible. I'm going to weld it with some box members. They'll both be the same dimensions. I won't make them scale one larger than the other. So we'll assume that since they're the same, I think this might be larger in real life. I have to check it. Hold on. Okay, now I'm going to have to scale it because that's an 8-inch chamfer. I don't think it would be fair if I just weld them together, butt it together. So I'm going to have to scale this to do that welded joint. So this will be helpful for us. This is when they put the pipes on. It has the measurements there. D1, D1D. Specifically, angle at the bottom is 51. Let me just follow that over again. 51.22 degrees. So this is 51.22 degrees. So when I do this one, I'll make it at 51.22. They're symmetrical. So that's why they look like that. So that's 51.22 here. Confirmation, if you guys see I'm wrong, you can speak up and I guess I'll just have to fix it. Again, that top angle is 37. I'm not concerned about that. That's the pipe. See the pipe length. Angle at the bottom, 51.22. And that's in line with number 10. So 51.2, that one I'm not sure of yet. We'll work it out. So before I end the video, you guys keep asking me to give you the short version. The short version is none of this bridge was tested besides dead load testing when they had it in the impound. I call it the impound, the staging area. But when it was in the staging area, they did not have detention number 2 and 11. Denny Pate and his in that meeting where the 2-hour meeting where they talked about what to do next, that was one of his statements that it was load tested in that capacity, but it was not load tested in that capacity because 2 and 11 was not detentioned over there in the impound. So it's a total different profile once they detention 2 and 11, as we obviously know with the cracking. Also, they didn't disclose all the cracking and twisting that apparently took place during the move. That's another profile that's been created for this structural profile, if you will, that's changed. They're claiming the twisting happened and some damage happened during that twisting during movement. That's what Denny Pate's people appear to be stating, his engineering, forensic engineer. I did talk about twisting in another of my videos. I stated that when I saw the detention, how it was the back of the bridge was torqued, I said, hey, this thing has a natural twist in it, a natural twist. So, and I put the video up saying, this is imbalance. There's an imbalance in this design. And sure enough, through their analysis, they show that it's got a natural twist in it. And if you guys want to find that video, I posted it 2 weeks, September 22nd, way before this release. And I talk about the torque here. Let me give you a quick little, it's going to be loud, hold on.
Inches.
Hold on, good sake.
So the span, so look at over here where my mouse is. So this has to be center line. Now imagine what happens if you could just take your hand now, keep the center line, and just push this to the right a little bit. If you were to push this to the right, this would create a lot of torque down here, wouldn't it? Right down here, causing this to fail here. Now with no supports down the middle. Now, let's just say the post-tensioning is not enough and the reinforcement's not enough to keep this 16-foot span here. See 16 foot?
Let's talk about that real quick. If this has a natural torque action to it, a natural torque action, then how can they post-tension everything equally and expect the torque action to disappear? So their forensic engineer is arguing that, showing there's natural torque action without post-tensioning at it. So it still exists if you add post-tensioning and you have the post-tensioning equal all the way down the entire deck. So part of my argument is, okay, they didn't. You sort of jammed Denny Pate up, because by that logic, the torque action still exists and there was no counter torque added for this torque action. I'm going to bounce to the report in just a minute. I'm going to find something else in this video for you. So in this video I posted just a couple days back, FIU bridge collapse, FIG's NTSB response leaves out one image that blows all of these fake reports up. It's the image of the crack in number 11. But I have this up because it was reminding me to do the video on the torque action. This is FIG's report, his response with his professional forensic engineers. And it says self-weight and post-tension effects are subtracted. No post-tensioning added. Well, it wouldn't matter if you added anyway, does it? Because it's all equal in post-tensioning. There's no extra difference added in there. So this torque action is 20x, it says. 20x somewhere, so for fairness, there it is up here, 20x. This torque action resembles this. It even has the deck. It's a twisting action going on here, isn't it? But here we go. So their own report shows that the bridge is not in equilibrium to begin with. It has a natural torque to it. I don't know why he didn't catch on. He shouldn't have put that in the report against Denny Pate. He should have been favoring Denny Pate, you would think. But the major torque action is down here in the red. Look at this in the canopy area. Isn't this where it cracked also? They don't talk about the next, they just want to blame it out here. They try to blame it on Barnhart for transporting and not staying in tolerances. Perhaps they're right on that. And create some torque action. Perhaps they're right on that. You remember me, I don't throw away the baby with the bathwater. I just want the data. I just want the truth pretty much. And if it goes against something I said previously, well, so be it. I just, correct my statement and we move on. So in other words, if Barnhart did create a twisting action, well, then we throw Barnhart under the bus. Maybe they created some damage there. But how did they address this 20x times, this torque action? How is that addressed? He doesn't state how it's addressed in the design. It's not addressed. It's equal. Everything's symmetrical, left and right, as it says in the plans. Let's play a little bit along with this a little further. He said no post-tensioning, right? So now let's add post-tensioning. Would that have the effect, the clamp force of holding this triangle that I call it? Remember, here's that bright red here, of holding this together better. And down here also, remember, there are different diaphragms. So this diaphragm is totally smaller. It's a different setup altogether. We do know there's a long crack diagonally down the center span now. That's been revealed, and I'll do that in a future video. I have to creep up on videos because I can't make a 3-hour video for you guys who lose interest. But that's what I want to share with you at this time.